All right, guys, this is our first lesson on Pythagorean Theorem. You should go ahead and cut out along the outside dotted line of your foldable. They're not perfectly straight with the front and the back, but it's close enough, okay? So when you have it cut out, go ahead and lay it down so this side's facing up. You'll notice that on this flap is where we're going to glue it. So let's go ahead and fold it like we're going to fold it. This side's going to get glued down, so just hold that. We're going to fold along this solid line. And then we're going to fold back along here. And it's not going to be perfect, but it'll be close. Okay. So we're looking at the Pythagorean Theorem. So we know that this is going to be a squared plus b squared equals c squared. A and b are both the shorter sides of our triangle, and a and b, they're going to be called our legs, where c is that hypotenuse, referring back to what we did in the last lesson. Today we're just going to be focusing on finding the hypotenuse. Okay, so let's open to finding the hypotenuse with numbers or drawings. Okay? All right, example 1. We have a 5, a 12, and an x. Well, we need to first identify what our legs are. Okay, so the shorter sides are the sides that make the L. We have that 5 and that 12. Okay? So let's see, we have one of our legs, we'll call that one A, and we'll call that one B. Well, we know that if A squared plus B squared is always going to equal C squared, the longest side across from that right angle is going to be C, or the hypotenuse, okay? It's going to equal C squared. So let's write that out. We have then 5 squared plus our other leg, which is 12 squared, and it should equal c squared. 5 squared is 25, plus 12 squared, which is 144, should equal c squared. 25 plus 144 is 169, and that's going to equal c squared. Okay? Or my x, whatever you're looking for, that's c or that x, same thing. Okay? Except for c does not equal 169, c squared does. You have to do the inverse operation of squaring something, which is square rooting it. When I square root c squared, I get just c then. And then I need to square root the other side. The square root of 169 is 13. So that hypotenuse, or x, is equal to 13. All right, example 2. Identify your legs. We have our little L by our right angle. We've got 7 and 24. Let's write it out. We have 7 squared plus 24 squared is going to equal x squared, because that's our hypotenuse. That's what we're looking for. So the sum of them is going to equal that squared. So 49 plus 576 is going to equal x squared. We know 49 and 576 added together is 625, should equal x squared. That is not the length of the hypotenuse. You still have to square root it. The square root of 625 is 25. Example 3. Our legs, making that L with the right angle, we have 8 and 15. 8 squared plus 15 squared is going to equal x squared. So 64 plus 225 equals x squared. Add those together, we have 289 equals x squared. Last step, square root x, square root 129. You're left with x equals 17. So that hypotenuse is 17. And our last example on drawings. Our legs, we have 9 and 12. 9 squared plus 12 squared equals x squared. Whatever that hypotenuse is, I don't know. It's called x. So 81 plus 144 is going to equal x squared. 81 and 144 is 225. And your last step, square root x to get it by itself. That's the inverse of squaring. The square root of 225 is 15. Okay? Pretty simple, pretty basic. This formula is going to work when we're just looking for the hypotenuse. Okay? All right, so now let's flip on to the inside into those word problems. Example 1. A support wire is attached to the top of a 60-meter tower and is tied to the ground 25 meters from the base of the tower. How long is the support wire? The best thing that you can do is draw a picture. Okay? So let's go ahead and read through our word problem one more time. So our support wire is attached to the top, that's going to be important, of the 60-meter tower. So let's draw that. So we have a tower, which is how tall? 60 meters. So let's label that. Okay? And is tied to the ground 25 meters from the base. Well, the base is not going to be at the top of the tower. It's going to be at the bottom of the tower. And it's 25 meters from the base. And then you can draw your support wire. Okay. How long is the support wire? Well, here we just have a right angle. That base and the ground, or the base of the tower and the ground, is going to make our right angle. So let's set it up. We have 2 legs looking for that hypotenuse, or C. We have 60 squared plus 25 squared is going to equal C squared. So 3,600 plus 625 equals C squared. Add those together, we have 4,225 equals C squared. At this point, you can use a calculator. There is one linked to my website, desmos.com, is a good calculator site as well. Find your square root of that right there. C is equal to 65. Okay? So the support wire is actually 65, what do we have, meters long. Example 2. The size of a rectangular television screen is described by the length of its diagonal, rounded to the nearest whole number. If the height of the television is 18 inches and the width is 32 inches, what is the length of the television's diagonal to the nearest inch? All right, well, first, let's go ahead and draw your rectangular television screen. Okay. And then let's label our dimensions. The height is 18 inches. And then the width is 32. I'm looking for the diagonal. So go ahead and draw your diagonal. Well, we know that rectangles have 4 right angles. So then we're able to identify our legs. We have 18 squared plus 32 squared is going to equal our diagonal, we're going to call it c squared. Well, 18 squared is 324. 32 squared is 1024, and that all equals c squared. Add those two numbers together, and we have 1,348 is going to equal c squared. Square root c to get it by itself. Square root the number on the other side of the equal sign. The square root of 1348 is, to the nearest inch, 37. Okay, so the diagonal, or the size of this television screen, is 37 inches, as it's named by the diagonal. All right, and example 3. The 8th grade math class keeps a flower garden in the front of the building. The garden is in the shape of a right triangle with one leg measuring 9 feet and the other measuring 12 feet. The class wants to install a 3-foot high fence around the garden to keep students from stepping on the flowers. The fence they need costs $5 per foot. How much will the fence cost? Okay? All right, well, let's look. We need to first go ahead and draw your right triangle of the flower garden. And let's label the dimensions. It says that one leg is 9 feet, and then the other is 12 feet. Okay, and then let's see. So then we're going to need to find how much, in the end, how much it costs to surround the garden with a fence. But first we need to find what that diagonal is. So we have the legs 9 squared and 12 squared, which is going to equal c squared. So 81 plus 144 equals c squared. So 225 is going to be c squared. Square root it. 15 equals c. So the length of this part of the garden is 15 feet. That's not what our question asks, though. It says that the fence they need costs $5 per foot. Well, if you're going to fence in this garden, we're looking at perimeter. So just how far around the garden is the fence going to need to go? Well, this is 12 feet plus the 9 feet plus then the 15 feet will enclose the garden with a fence. So that is 36 feet of fence. That still doesn't answer my question. I now know that it costs $5 per 1 foot, and I have 36 feet. I'm going to multiply by 5, because that's our money, by the $5 to figure out how much the total costs. 36 times 5 is $180. Okay? All right. So pay attention. I need you to glue this down as far to the left as you can on page 105. We need this right space for the next unit, okay? And you can go ahead and complete what I've assigned as your left-hand page. You received it in class. The code word for today's lesson is Superman. Go ahead and get that signed. Don't glue in your left-hand page until I've checked for understanding. If you have any questions, email me as soon as you can.